Hello guys, welcome back. In this video, let us see one more ML based classification. In the previous videos, you have understood ML based classification, that is ML based categorization, that is a classification. This ML is categorized into two ways. One is a classification and another one is regression. Based on the type of task we are performing, these ML models are categorized into two ways. So one is a classification and one more is regression. These are the famous algorithms, ML based models that we use for classification tasks like logistic regression. We have already seen an example on it. Navy bias, we have seen an example on it. And support vector mechanism. This support vector mechanism actually, in this support vector mechanism, what we will create vectors to separate different classifications. We create vectors here. Whereas in this KNN, like K nearest neighbors, in this KNN algorithm, we will identify like what are the nearest in this KNN. If we consider like this is the center point, so from here till this circle, so whatever the data points are there, those we consider into a class. Whereas in this circle, in this middle circle, whatever the data points are there, those we consider as one more category of class. Whereas in the outer of these circles, we will consider that data points as one more class in this KNN algorithm. This is about logistic regression. Like in this logistic regression, we'll classify the we will do classification by using either 0 or 1. Here we use this sigmoid function. In this sigmoid function, this z represents the transformation, where this z is nothing but we'll get this z based on whatever the input data or x points that we given. Based on that x points, we will we will pick the corresponding weights, and based on that data we will identify this b and we'll identify this z. So based on that we'll identify this g of z. So based on this g of z we will categorize the point in between 0 or 1. So if the point is above 0.5, we consider it as 1. If this g of z value we get as less than 0.5, we consider that as 0. Like if we provide any input, then obviously our model will generate the weight for that particular input. Then by using those two and by using this b variable, this z will be identified. Then after, to categorize the given value of x or data in between 1 or 0, that is nothing but belongs to this category or this category, we'll use this sigmoid function while training. So when do we get this b value, sir? While training, we will provide both x values as well as the output values that we are expecting. So during that time, these weights also we are providing. So during that time, this b will be predicted. So this is a logistic regression. So here also we are classifying the given input into one of the category, either 0 or 1. This is how we can classify the data in logistic regression as well as a KNN. Now let us see in Navy bias how we classify this data. So to classify this data, we are using, you can see here we will consider, here we'll categorize this data based on Navy bias, or you can say what are the probability theorem that is proposed by Bayes. So by using that Bayes theorem, we'll consider each and every category related probabilities and we will identify the whole probability. Based on that, we will classify each and every classification. And even that classification is also working very well, even though we are considering different input categories into different probabilities. By using this Bayes theorem, we are considering or categorizing the given input into any one of the category. Even that is working very well while implementing in practical as well. Now let's see decision tree. So how the classification happens in this decision tree. If you observe here in decision tree, so we are identifying so how much percent the candidate or the patient will be affected if dosage percentage is this much. Let's say if the dosage is less than 14, if it is true, since the dosage is less than 14, the candidate or the patient will affect 4.5%. Or else, if it is false, then dosage is greater than 29. Either it may be true or it may be false. If the dosage is greater than 29, then 2.5% the patient will be affected. So in the false case, if the dosage is greater than 24, then so if it is true, then 53% he will be affected, and if it is false, then 100% he will be affected. So like that, we can make a decision based on true or falses. Based on the condition, we can make a decision in the decision tree by true or falses. And we can able to categorize this data, what are the input data in between any one of the categories or multiple categories. And after this, that is after this decision tree, random forest algorithm came. So that is the advanced version of it. That is this decision tree. Whereas in that, the major thing happened is in that random forest algorithm. So that is the extension of this decision tree. There we will take multiple decision trees in order to consider the effective classification. We will take multiple nested decision trees under this random forest to classify the given input into specific category. So those are about these all classifications related to ML models. Like that, actually the classification happened. Whereas coming to here, so in the regression model, here the given input is predicted here. So basically ML models are of two types. One is supervised ML models and the other one is unsupervised ML models. In unsupervised ML models, what we will do is we will do clustering. Unsupervised ML models are there. So here clustering happened. Whereas in the other things like in supervised machine learning, the classification as well as the regression we can able to do. So in unsupervised learning, we can able to categorize the whole input or categorize the input data into specific clusters. We'll fit the given data into specific clusters. The difference, major difference between these two are supervised ML models as well as unsupervised ML models is nothing but based on the given data, given input data, these two are categorized. If the given input data is labeled data, then we can say that data as, then we can consider that type of machine learning model as supervised machine learning model. And in the supervised machine learning also, if we exactly predict the output into specific category or classification, then it belongs to classification type ML model. Whereas if we are unable to classify exactly and we are predicting the output Like, what is the weight of a cat? So if the cat photo is this, and this is the face of the cat, and what is the weight of the cat? So that belongs to this predicted output. We cannot able to classify the cat's weight. Let's say if I provide a cat photo and if I ask that photo is related to cat or dog, then we can exactly predict it or classify it into cat only. So that's why that cat prediction is nothing but exact output. If we provide the input or cat photo with marking the cat face as a label, then we say it's a supervised learning. Like since we label the input data, if we haven't labeled that data, we provided the given input, like we haven't marked any face of our cat and we just provided the input, and we are categorizing or clustering that data into specific category, then it belongs to unsupervised machine learning process. Now let's see one of the small example on this regression as well. So in this also multiple famous algorithms are there. So among these, let's see this linear regression hands-on. To implement the linear regression, you can see we imported this linear regression method from sklearn from linear models. And we have taken an example like we want to predict the prices of house based on the size. These are the sizes of house, like square footage, and these are the prices in thousands, like 300,000, like that the price will be. So for this is the price. For this is the price. This is the price. So like that we provided input x values related to the size and output y values related to the price. Now we splitted the input text into training data as well as a testing data by using this train test split method. That also we imported from sklearn model selection only. Then after we consider the test size will be 0.2. So and then we created our model. Then we are training our model with our training data set of x and y. You can see we trained our model with this fit method. Then after we are predicting. So what is this a mean square error, sir? This mean square error will actually identify the accuracy difference between our model prediction and actual output. So actually we split our input data into two data sets here, and with the one data set like training data set we trained our model, and with the testing data set we are testing our model and finding the mean square error in order to identify so what is the difference that we are getting with respect to predicted and actual. We are importing that mean square error also from sklearn metrics. Then yeah, you can consider here we are printing the mean square error of y tested as well as y predicted. So we are predicting the y values based on providing the x related test data. This test data is nothing but what are the data that we split from the given input. So then after at last we are also providing the model coefficients like intercept as well as slope coefficient also we are providing. So at last we are providing a new input like a new house house square footage we are providing, and we are asking our model to predict the cost. So this is just a prediction of cost. So since it's not regarding a classification into specific category, we can say it relates to regression type model. So since it's a linear regression, now I'm just running this to see the mean square error that I'm getting. If I use this linear regression model, and let's also see this output as well. You can see here mean square error that we are getting is this, and intercept is this, slope coefficient of linear line that is this, and this is the predicted value of a price for this much amount of square feet of house size in that area. In practical, this is how the graph will be like. This is the linear regression related line, and the data points will be present at a top as well as at down. So here some inputs are there. So and here the inputs are there. So like that we have the inputs. Whatever the nearest line which is possible, that will be considered as our linear regression related line. And based on that, we are predicting the output. Since we are not considering the exact output, so we will definitely get some error here, that is a mean square error that we get in terms of cost. Variation happens in between actual output to expected output that we predict from this linear regression. We can even minimize that with some advanced algorithms also, but this is how actually we can able to implement this linear regression algorithm, as well as this is how the model will look like, and this is how we can able to implement it in real time. So I hope from this video you'll understood the ML classification as well as supervised machine learning classification and multiple classification related ML models and regression related supervised ML models. I hope you understood from this video. I hope this video is useful to you. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.